So in this video, I'm going to take you through how to use the same 3 trigonometric ratios, but instead of looking for the unknown side, we're going to use it to find an unknown angle in a right angle triangle. So don't forget, always remember that opposite and adjacent is always dependent on the location of the angle, and the hypotenuse is always going to be the side that's opposite the right angle. It's also the longest side, but the easiest way to determine what that side is it's always the one that's opposite the right angle here. We're going to use the same 3 ratios, just like we did last time. However, what we're going to do now is, instead of looking for a side, we're trying to look for theta. So all the angles here are going to be our unknowns. Now we can arrange each of the 3 ratios slightly to make the theta the subject. Now the reverse or the opposite of sine, so if you want to get rid of the sine, I do sine inverse to both sides of the equation. So what I technically will get will be theta, so the angle, is equal to inverse sine opposite over hypotenuse. Okay, it's the same ratio, except now I've just rearranged it so I'm getting the angle instead. Over here, it's the same thing. The inverse of cosine, or the opposite of cosine, is just inverse cosine, adjacent over opposite, and the opposite of tan, or to undo the tan here, you'll do the inverse of tan onto the other side. It's not tan -1. This is just the symbol for the inverse of tan. But the ratio, SOHCAHTOA, still applies, except we're now looking for the angle instead and using sine inverse sine. And to pull out inverse sine on your calculator, if you have one of these, it's the shift button and then one of these buttons here. Now the shift will bring you to any of the gold buttons, the gold symbols on the top. So you can see that above the sine button you have inverse sine, above cos you've got inverse cosine, and then inverse tan as well. So how do we apply these? Well, let's have a look at this example over here. Now here I've been given 2 sides. This is a right angle triangle, and my aim is to determine the unknown angle here. So to do that, all I have to work out is, well, what do I actually have? If this is the angle, this will be called the adjacent, and over here would be called the opposite. And out of the 3 ratios, the only one with adjacent and opposite would be this one here. And all I basically do is fill it in. Theta, so my angle, is equal to the inverse tan, open bracket, opposite is 300, over hypotenuse is 400, close brackets, and all I do is type that into the calculator. So inverse tan, and it's 300 over 400, close brackets, and I get 36.87. So 36.87, and because we're looking for an angle, this unit will always be in degrees. Okay, so that's my unknown angle there. If you wanted to find all 3, you remember that angles in a triangle always add up to 180, so if you know 2, you'll know the 3rd one. Let's do another one here. Once again, we're going to establish what we have. I've got an angle here. This side is always going to be called the hypotenuse because it's opposite the right angle, and here is the adjacent. The only ratio that has hypotenuse and adjacent would be the cosine, this one over here. So all I'm going to do is copy that down and replace everything I know in it. So it's inverse cos, then open my bracket, adjacent is 2.5, hypotenuse is 5, close bracket, and all I do is type that into the calculator. So shift, it gives me the inverse of cosine, 2.5 divided by 5, close brackets, and I get 60. So 60, what exactly? 60 degrees, because I'm looking for the angle in a right angle triangle. And that's how you do it.